Hello everyone, I'm very happy that you can attend this CATIAJewelTalk number 17. So it has been a long time now, and the subject probably you will enjoy it, because a lot of people talk about parametric design, associative design, update, links, whatever, and CATIA is probably one of the best solution on the market to do in a very industrial way and to implement in a very industrial way what we call relational design. And why so? Because in fact we have this capability of using what we call the skeleton approach. Sometimes people call that the top-down approach, and you will understand probably why. And I am glad now to introduce to you, I'm sure most of you know, but it's always good, to get a refresh, okay, on skeleton design and use of skeleton. So let's start. So what you see here is just an introduction. In fact, in CATIA, there are two types of links, okay? The first one is called rep-rep, a link between a representation or a part and another representation and another part. This type of link should be used when you are only using one single axis system for your complete product. Okay, it's very important. Why? Because we make a link from a part to another one, but we don't take into account the position of the part instance in the assembly. Okay, but it has some advantages. Okay, so this is the first type of link, okay? What we call the advanced multi-part design. The second type of link is called a contextual link, okay? In this case, you are within a given product called the context product. In this product, you have multiple parts and instances of parts, and you can make link between those. And as you are inside the product, the information of what link is between what part and what is the position of those instances is put in a in a product. So, and this is a root product. So in this case, we will take into account the part instance position. Okay, so rep link, contextual link. By using those two, you can do a lot of good stuff. Very important. So now that we talk about the two type of links, we have some other, okay, in the 3DEXPERIENCE platform, but we have also those two one. Let's talk about the skeleton methodology, okay? The idea is very simple. You have a product. Inside the product, you will start with the skeleton of the product. And then inside every single sub-product, sub-product, and part, you will also have some copy-paste with link of the part of the skeleton, which makes sense for this given sub-product, sub-product, or part, okay? So the idea is really to create dedicated part or shape, but I prefer to talk about 3D parts, where you will have those driving elements of your architecture, okay, which is wireframe element, plane, lines, surfaces, or any parameters, okay? And it will allow you to drive the position of those parts in the product. You can also add any other specification like space reservation or other properties that will be useful for you when you are designing a part or a sub-assembly or a sub-sub-assembly. So that's the skeleton methodology. How do you implement this skeleton methodology? By using just the links that I was talking about, multi-part design, the rep links, but also the conceptual part design, the contextual link. You will use also publication, and I will explain to you what is a publication. And you will use, most of the time, the impact graph. You can see here a picture on the right, to navigate on links, to know what is impacted by a modification of your part, and what are you impacted by when you are designing a part, okay? Furthermore, you can add, if you want, and I will show you that later on, the use of engineering connection and contextual engineering connection to put in position a product or a part in a sub-assembly in respect to a given existing skeleton. This is a skeleton methodology or top-down approach, and we'll see some of the way of doing that. And the most important way, or let's say capability of 3DEXPERIENCE CATIA, is publication. What is publication is very simple. You give a name to a part element. You give a name, surface top, surface bottom, spare one plane, to a geometrical feature or to parameters, okay? By using this publication, you will be able, instead of clicking on the geometry, to position part in a product directly by clicking on the spec tree in the name, on the name of the publication. So you can control the position of the part in a product. You can also design in context using those published elements, and that without again clicking on the geometry. Most of the most complex things when you do parametric design is to be able to achieve a very easily updatable product when there is a design change, okay? If by mistake you click on a surface in the 3D session, if the number of span or surfaces in the surface you are clicking is changing, you might create an issue which is not at all happening when you use publication, because you give a name to a geometrical entity, you are clicking on the spec tree on those publications. Very, very few software offer this capability of doing that, and it was existing in CATIA v5, but we have also improved the capability in the 3DEXPERIENCE CATIA. And if you do that properly, you will be able then to reuse an existing part or product within a given root product, or even change the context root of a given part of a given product without any difficulties. This is extremely important. Publication is one of probably the best jewel of 3DEXPERIENCE CATIA. It allows you to generate and to design very, very complex products and ensure a very smooth, straightforward relational design, okay? Something that you have also to know is that we are in 3DEXPERIENCE platform, the publication, this concept is at the level, product of level, are really an object, a PLM object. It is managed as a single entity known by the platform, okay? This will enhance the integration of all those links and the management by the platform, thanks to the management by the platform. And of course, if there is any issue, one of the geometry which is published has changed, and the entity which is linked to this publication it has to be modified. There will be a synchronization status. You know, in a very, very simple way. I will show you that later on. If the part is synchronized with all the publicated element he is pointing to. So we'll see that in detail right now. I hope, I'm sure some of you already use that, but okay, let's see what is happening. So I am a wing architect. I am in a company doing planes. So I start my 3DEXPERIENCE CATIA. I search for the aircraft data, and thanks to the 6W tags of the 3DEXPERIENCE platform, I can search, because there might be a lot of data with the name aircraft or the wording aircraft. I will search with the responsible tag. There are multiple other tags. And I will say, okay, let's to check what the aircraft architect made. Only 2 parts. And I will open the first part, which is a product in this case, which is the aircraft assembly. So I select my object in the result of my search, and then I select the assembly design application of the 3DEXPERIENCE CATIA. Here we go, we launch CATIA. So in my case, I'm using CATIA on the cloud. As you know, almost everything related to CATIA is available as on-premise, but also on the cloud. And this is my product. So now I will insert a new product in my existing design, which is in fact, so this aircraft product might not be mine, okay? I'm just the wing architect. I'm not the full plane architect. So I will insert my own product concerning the wing. So I insert a product, I give the name, wing, whatever. Here we go. So the wing DMU, digital mockup. So then I will continue to instantiate or create a new entity. Let's put a 3D part, and this 3D part will be my so-called skeleton part. Okay, so let's call it wing skeleton. It will contain all the driving element or driving parameter, that is the master one, which are driving all the other design. So let's create now a 3D shape, the wing skeleton, and I can here do everything I want. Very first important things to do is maybe to look at the skeleton at the aircraft level to maybe recover some important parameters or geometries that I can reuse or which make sense in my wing design. And I will therefore open to screen the aircraft on the left side, the wing skeleton on the right side. I'm today concerned on the wing skeleton on the right side. So what I do is very important, this small dialog box. I will create an import. What does it mean? I will select in the other product or in the other part some geometries, some parameters, and I will copy paste those parameters into my product and part. I can, this is also important, I can import them with or without the context. If it's without the context, it will be a rep link. If it's with the context kept, it will be a contextual link. So here are some publications that have been done by the aircraft architect. So the top surface, there are some sections, the bottom surface, there are also some sections. So I just take all of them and import this information in my own wing skeleton from the main aircraft skeleton part. Here we go. We continue. You can see here all those publications. They were hidden, so I just turned them on to see them. Oops, here we are. So I have some sketches. I think that's it. Now I will just save my design. So my, let's say my architecture, my main skeleton of my wing is now almost started. And I will just look now to the links. So let's first explore the whole aircraft. This is a whole aircraft exploration. And I will expand all sub-levels of my data. So you can see the aircraft skeleton. You can see my wing skeleton. And now I'll do an impact analysis. Okay, very important. You see on the left, this is the impact on the aircraft skeleton, and there are some links, publication, surface bottom, the section, and so on, top, surface top, and all the sections. You can see the type of link. Here I will just explain to all the level and sub-levels of my impact analysis. And this is a very important tool. You will see that we are using this tool almost every time. Everything we are doing, we double check that the links are perfectly well defined. It's not that complex. It's not cumbersome. Okay, it's very easily done. So it's also an help for the designer to double check that he properly designed in relations. So you can see the type of link. You can see what is pointed by, what is on or off, because sometimes some links are dead. So you will see the thumb down. And it was fine for me. So I created my rep link thanks to the publication. And now I will just, as a wing architect, enrich my wing skeleton. Add many other entities, many other planes. You can see that I add also some pathways, trajectories, where I want to reserve some area to put cables, to put tubes, whatever, pipes. And my job is almost finished. But before that, as I know that my job is to define the architecture of the wing, there will be some mechanical designer in charge of the mechanical parts. I want to give them all the relevant parameters to be used by them to do their design. So I will add, for example, here I publish, this is this button, I publish the top surface. I will keep the same name. I could have given another name than the one coming from the skeleton of the full aircraft. I will also publish the surface button. You can see what are the pointed elements. What is the pointed element in this particular case? I will add other information like the spar planes. There are two spar planes. There is a main one, some limits. So you see, I define which is relevant to my design to perfectly control what will be passed to the downstream processes of designing the detail the individual parts of my wings. Okay, that's my job, almost finished. This is all my publication. I'm fine. I will now probably switch my head, and now I am the mechanical engineer. As a mechanical engineer, I will open the product, the main product, aircraft. In the aircraft, there is the skeleton of the aircraft and the skeleton of the wing designed by the wing architect. Oops, sorry for the jaggies. So I will create a new part. Let's design the first rib. The first rib will use what has been published by the architect. So probably the planar section, the top surface, the lower surface. I don't know if this part will have some relation with the spar, but probably. So those are the elements that I'm using. And I will again import in my part what I need to use for my design. So if you see here, the import I made is with keep context, which means that I'm creating, in this case, a contextual link, which means that I need at any time, if I want to do a proper modification, to open the product which was used to store the context information. Okay, this is my surface top. I also import the bottom and so on and so on. So I have myself. I could have do a copy paste as result with link. It was what was existing with V5. Let's do that for the surface bottom. I will copy paste as result with link. Here we go. But it's exactly the same capability, just a little bit more complex than the create import. And now I have in my data my published entities that I am using for. So let's start to design the rib. So let's create a sketch. So that's not a big deal, okay? I will just create the dimension of the rib and split the rib by the top and the bottom surface and add some other elements. This is a detailed design stage that I am used to do as a mechanical engineer. That's not something new. Remember that in CATIA, we are trying to give to the designer as much as we can of the 3D. So not a lot of menus, whatever, a very, very few number of menus. It's very important to stay focused on the 3D. So in this case, I will create my split. Here we go. And I will split this pad by the top and the lower surface. Here we go. The split by the lower bottom surface, sorry. Here we are. And I will just hide the published elements that I was using in my design. They are there. My rib is split, and I will continue my job for all the other ribs, obviously. Here we are. As you notice, I am quite fast to do my job. So let's open the rib. And you see, I'm now opening the rib in a part. Okay, so it's a part, but the part does not contain the information of the root. It's why there is a small logo, small symbol here to tell me, hey guy, watch out. You cannot do whatever you want, but you see here the part. I am out of context now. Okay, it's not that big deal. Huh? Sometimes you want to do some small modification in the part. So here's the part in my context. I have all my external references. I just close my part. Everything's fine. And of course, I want now to save my data in the 3DEXPERIENCE platform. By the way, on the cloud, because I'm using an on-the-cloud version of 3DEXPERIENCE CATIA. The save is successful. Remember, the cloud, it brings a lot of flexibility. Huh? You don't have to do backup. You don't have to take care of where is the data. It's very, very cool from an IT point of view. So let's open again the aircraft. So I will just explore it because I want to look at the links again. So I open the aircraft product and I will just expand, let's say, up to the second level, my product structure. You can see here that we have all the ribs that I design in my given product. You can see them on the left in the spec tree as well. And I will just do an impact analysis again. It's important because when you do that, you double check what you are doing, okay? So now if I look at impact on, I see the wing skeleton, and I see all the original surface and plane sketch which were used. And if I expand it, I can see that there is a publication link with the aircraft skeleton from the wing skeleton. And if I look now at the tab impacted by, there is also some links, but it's no more a rep link, it's a contextual link. So this part has been created in the context of this product. So you can really check the hierarchy, the links between the parts, the sub-product, sub-product, and the root product. So if you have any issue, it's very easily, you can very easily navigate in the tool to double check what is happening and what is missing. Okay, that's it for me. I think I'm fine, but I still want to double check the impact on the part called rib01, which is here. And again, let's check. Let's see what is impacting rib1. So there are some contextual link. I will just expand to 3 levels to have all the other levels of the hierarchy of my impact analysis path. So you can see here the stuff. So everything's fine. I'm glad with that. So I know how the part was created, what is the hierarchy inside my product, what is depending on, and what is impacted others. Okay, now I'm always fine, and I am now the wing architect. So you saw the skeleton part, the part is depending on the wing skeleton. Let's now see the beauty of the relational design and the skeleton approach at work. I am back, I took my wing architect cap. I go now to the collaborative lifecycle application of the 3DEXPERIENCE, and what I will do, I will lock my wing skeleton parts. Okay, I don't want anyone to touch it, so I lock not only the reference but also all instances of this wing skeleton made by my peers. Okay, I don't want them to modify them so far, and I will do the modification because I am the guy in charge of the modification, and I will, in this particular case, change a pathway geometry a little bit. And you will see how these changes are propagated to the mechanical designers. Okay, so let's go to the sketcher to modify the pathways. It's a small modification. I will just change a small fillet. I go back to the invisible world to retrieve some of the data I need. So I go to the sketch. Here we go, and I will change this fillet value. It's not really a fillet, it's an arc of circle. So here we go. So I had a radius of 100. I will change it to 120, 25. And you see this line has changed, but also some other line has changed on the left. So I have brought, I touched 2 geometry. In fact, the 2 pathways which have been published, the number 2 and the number 3 have been modified. But that's my job. It's what I decided to do. You can see there is some symbols on pathway 2 and pathway 3 because I changed that. Okay, let's save. I did my job. Let's have a look at the impact that I created because of this modification. And if I look at the impact, there are some, of course, there are some modification, and we can see the impact. We can see what is impacted by my design change. Oops. You can see some of them are okay. So some up. Some of them are not okay. Okay. Some parts are depending on the pathway 2 and pathway 3 geometry that I changed. So there are some down. So at least I know what is impacted. And now we'll see how the mechanical designer is taking into account this design change in his job for the ribs. Okay, so I'm back as a mechanical engineer. I will search for my wing DMU. I will explore first to see what's happening. First sign, I see that the swing skeleton is double lock, okay? Both instances and references. Something has happened. Here we go. So let's just do what we call business intelligence essentials, which are a set of non-geometrical property like maturity, like design links, like in my case, I will check the reservation status, which are displayed in a color-coded way, both in 3D and on the spec tree. So I see that someone reserved this geometry. It is locked. Okay, at least I know the information. And I want to double check what has been done. So I run again impact analysis. You see the wing skeleton, which is double locked. Let's again expand the complete hierarchy and sub-hierarchy of links in my impact analysis, and we will see what is the problem or where is the problem. All those guys, those contextual links, are no longer synchronized. So I can filter the display by just showing what is not synchronized to simplify the display. Sometimes it can be very complex, okay? So now I know what I have to do. The pathway 2 and 3 have been changed. So I have to update, to synchronize those changes to my parts. So I will just click for the first one on all the ribs I would like to synchronize. So I just click them and open them in CATIA. Here we go. This is it. And I do my job of synchronizing everything. So let's have a look at the business information intelligence essential, and look at the synchronicity status, as I call it, but it's more called update and links status. Here we go. And it is displayed in a range that there is out of data of some links, so they are not synchronized. It's not like an update, it's different, okay? An update is just affecting the part itself at the feature level. Here, it's a part which is where I point to, which has been modified, so I have to synchronize. The good news is that in 3DEXPERIENCE, synchronization and update are no longer in the same. So you don't see everything in red when there is a design change. You see some differences. So here it's just a synchronization issue. It's helping the designer to make the proper and more efficient way. So I'm just now updating my various parts which have been not synchronized. Here we go. That's the beauty of 3DEXPERIENCE CATIA and relational design and skeleton at a glance. Looks easy, but that's not easy. And you can do similar things on surfaces, complex surfaces. And thanks to publication, because when you are doing surface design, most of the time, the surfaces are the changes are so drastic that if you were not using publication, you would be in trouble very, very quickly. So now it looks like everything is fine. I did my job and I updated everything. So everything is now perfectly synchronized with the architecture change of the wing made by my wing architect. So I save my data. I cannot save one thing. Let's see why. I cannot save the wing skeleton. It's normal. It's not my job. It's not my part. It belongs to the wing architect, and he locked it. So I just exclude this entity from my save. At least it tells you. 3DEXPERIENCE CATIA tells you that there is a problem, and at least you know what is happening. So here we go. I'm fine. Good job. Now let's move to two other capabilities of 3DEXPERIENCE CATIA, which can be also complement what I just showed you. And first of them is the engineering connection. You can also use engineering connection to move for example, a given part. I have this given part. I create an engineering connection between this axis system, which is on the rib, and another axis system, which is on the rest of the frame. Okay, this is this rigid engineering connection made between the two axis systems. Okay, and I can use now. I know that they are linked together with an engineering connection or in context engineering connection. Here we go. This is just to show you what is linked with the engineering connection. And now let's modify just the position of one of the axis systems, the axis system of the rib itself, for example. I just move it. I can move it with a compass. Here we go. That's just if you want to do, very quick design changes. You do not really have an idea of how much you move it. But thanks to the engineering connection, the position of the rib will follow the modification of the axis system, which was made at the spar part level, and we made a modification. That's another way to complement what we did with the skeleton approach based on the contextual and rep links. Another nice capability of 3DEXPERIENCE CATIA, which is not, let's say, was not existing in CATIA v5, is what we call assembly feature. So let's have a look how we can use assembly feature capability. So this is my assembly. Inside the assembly, I might have, a particular tube or pathway or cable, which is the blue one you see on the screen. And we'll see how we take into account this element that we added in the scene. And we want to just create a cut, an assembly cut. There are multiple types of assembly features, but here it's an assembly cut. And I will cut my 3 ribs by this blue geometry. So you just select the cutting element, which is so-called the sweep 4. It could have been, and it was, in fact, it could have been published as well. And then you select what will be cut by the blue element. Here we go. I just update, and automatically the holes inside the ribs have been performed. You will be able to see them in this body. I just hide now the element. You see the holes. Okay. This is also a nice capability of 3DEXPERIENCE CATIA. If I take one of the rib and I open this rib into part design, for example, or generative shape design, I see in the impact manager spec tree that there is an impact. Okay. And if you click on it, you will see the type of feature which has been used. There was a solid impact. It created a hole. And by the way, if you want, you can also propagate technological result. Technological results are manufacturing information that you can, or not, it's depending on the settings, used. For example, these technological results might be a tolerance that because it was a very, very accurate hole, for example, and you will get the tolerance, or even the PMI, the so-called functional tolerancing annotation, which will appear and be conveyed through the technological result. So here we go. Oops, sorry. This is the information I wanted to show you. And we are fine now. Everything has been updated. If, of course, now I change the elements that I use for the cut, for example, let's move 1 point of the trajectory of the strip. The cut will be automatically updated thanks to the assembly feature capability of 3DEXPERIENCE CATIA. So that's what I wanted to show you. A very important slide. Do tips. Very important. Only use publish parameters or geometry where you create engineering connection. Publish all interfaces of parts and products at instance level. When you use skeleton and when put them primarily in 3D part, because then the publications are stored inside the part, the life cycle of this part is autonomous from the product. And after modifying or editing a part, with published geometry, you can easily update the product containing the ones to propagate modification. So that's very important. Use as much as possible publication. Now, I think we are almost there at the end of this presentation of relational design using skeleton. As I mentioned earlier, it's also nice. The synchronization and the update are separate. So which means that if there is a design change coming from either a part not synchronized or an update to be done, in V5, everything was red. Now you can separate the problem, not the problem, but the cause of what has been changed. So that's very important, the part synchronization and the part update. It's just ease the work in case of design change. And now to finish, I think relational design and use of skeleton is just a must. Okay, when you design a product using this approach, you can easily modify the part position. You can easily pass a top-down design change to the very, very last part of your big product. You can easily distribute specification. You can easily take a part and change its context. You can easily reuse product, put them in another root context. Another user, the one which are not designing your part, can understand where are the links, what is driven, what your part is driving, and so on. It's really a must, and I recommend you and I encourage you to use this approach as much as you can when you are doing, of course, complex products, but more and more, I think everybody is dealing with complex products. So I hope you enjoy this topic. Sorry for that. Maybe Anne will add some words.
Yes, thank you very much, Daniel, for this for presenting these powerful capabilities and approach. I think we have 3 questions yes, for you from our audience. So maybe you already answered to some of them. Let's check together if you agree. So from Charlie, the question is, why is the aircraft skeleton a 3D part and not a 3D shape? Isn't a 3D shape a better choice for a skeleton because it cannot move in the assembly, and also it doesn't appear in the build of material?
You're right. You're right. But 3D shape has these advantages, the 2 you mentioned. The fact that the part does not move, and the fact that the 3D shape does not occur or does not happen or be produced in the bill of material. But it is not if you have it's not, you cannot isolate it. It's a 3D shape is inside a product. Okay, a 3D part can be isolated. It can be independent for the various product. You can reuse it very easily from one product to the other if it contains, a lot of entities. And yes, you can do with 3D shape. No, I don't think it's the best way. But there are 2 schools. And the good news with CATIA is you can use either one school or the other, depending on your constraints. But it's a good point. Thanks for asking.
And thanks for answering. And the second question from Vincent is, what part do you use to drive the design? How do you choose?
The design, the skeleton is just one part where you put all the master elements, the master geometries, okay? And it's up to you to decide what you put inside. Sometimes you don't know. You start by just making, the big 3 planes, 2 lines, whatever, outer surface, for example, of the wings, and then you enrich. Most of the time, it's what you do. You don't know at the very beginning everything which should be in the skeleton, but you can enrich. It's why it's good to have it on a part, not on a shape. But
okay, and we have several comments regarding the fact that maybe it's not so different from what people can have in V5. So I think you already commented on that too, Daniel, but can you recap maybe what we already have, but what is new with the 3D experience?
Yeah, indeed, for this particular topic, what is new is that, as you said, I showed you, the synchronization and the update are separate. In the V5, if there was a synchronization issue or an update issue, everything was red. Okay, so you cannot distinguish. Now you can distinguish. Okay, so it helps you to understand what's happening in case of design change. What I show you also is the engineering connection. In V5, you did not have engineering connection. You have assembly constraints, then you have kinematic joints. In 3DEXPERIENCE CATIA, engineering connection takes the best of both worlds, and you have only once to define how parts are stick together and located together, maintaining position in the assembly. In V5, it was 2 steps, especially if you want to do kinematics. And another important topic is the fact that everything is on a database, on a platform. In V5, those links, you saw the rep link, they were from one file to another, and they were stored in the file when it was a rep link, and they were stored in a product, another file, when it was a contextual link. Let's imagine someone deletes a file by mistake. You are screwed, okay? It's very complex. In the 3DEXPERIENCE platform, all those links are in the database. There is no problem anymore of ghost link, looking for a file for hours just because the file has disappeared and some pointing entity is no longer existing. So it's more reliable, more robust, faster. It has a lot of... CATIA V5 is good, okay? Don't misunderstand me, but it's much, much more efficient.
Great. Thank you very much for this clarification, Daniel. So, and thank you all for attending. If you want to continue the conversation with Daniel, please go to the CATIA user community. It's very easy to access it. You can see the link at the bottom of this screen or in the middle of this slide. So you just enter go.3ds.com/CATIA. You will have to fill out a DS passport if you don't have it yet. And this is where you can watch, but let me show you. We are in the CATIA user community now. So you see that there is plenty of posts, articles, but also other kind of media, videos, and so on. And if you want to look to something specific, you can search. You can use this search bar here and see what you have there for relational design, for example. And you will see that there are several posts, of course, and also people who indicated this tag, this word, in their profile, so that you can use this also to connect with new people and ask questions, in addition to continue the conversation with Daniel, of course.
By the way, I just want to thank Alain Dugousset. We just saw Alain Dugousset post because I used all Alain Dugousset material thanks to him. Thanks, Alain. It's very good stuff and he's very, very expert. So don't hesitate to use this community to chat with him. He's an expert guy. Top gun.
Great. So thank you all and talk to you soon. Bye for now.
Bye. Thank you for attending and hope to see you soon for the next talk.
Sure.
And enjoy the